So what I wanted to talk about today was essentially sort of how we have thought about securing AI. I am from the Mandiant consulting team at Google Cloud. So what I'm specifically going to be talking about are the things that we have seen working with customers. So this is not about like internal Google or Google Cloud. This is about what we have thought about and sort of how we're looking at and working with our customers. My specific role is leading a team of penetration testers. And I've been doing that with Mandiant now for nearly 16 years. So it's been quite a ride. It's been a lot of fun. So let's kind of dive into it. So where I wanted to start was sort of conceptual in what do we see and what do we actually kind of mean when we talk about AI at this point. I know a couple of people have talked a little bit about it, so I'll just kind of go through this kind of stuff pretty quick. But generally speaking, there are definitely different perspectives of what is AI, what is machine learning. But when I think about it from a security perspective, what I kind of want to do is try to understand what the attack surface is going to be. So for the next couple slides, I'm going to think about like, well, what is an agent? What is an LLM, et cetera? But how does that affect the attack surface? And what risks, et cetera, might be introduced because you have this AI thing that is out there? So, kind of first things first, or I should say perhaps last first in a way, an agent, which is kind of the new buzzword that everybody is thinking about, is an LLM. It's a thing that can do something. It can act kind of upon the world using some set of tools. And that's kind of an important distinction, but not everything is that. Right? Some of the things that we work with, I think there was a reference before to MCP and how that might enable an agent to do something. An agent might be able to say, send an email. It might be able to search. It might be able to do things on behalf of a user. But in some cases, a Gen AI application is not actually pulling content, or is not doing something. All it is doing is retrieving and presenting information. Probably the simplest version of that is, just a Gemini or a ChatGPT that's just got world knowledge built into it. It's trained in that way in the foundation model. And that's it. It knows what's available on the internet. Perhaps it's got some way of getting real-time information, but generally speaking, it's just regurgitating what it already knows. In other cases, an application can be provided with information through some sort of retrieval augmented generation, or RAG, that adds in some interesting context that makes the LLM that you're working with aware of something. And this is going to become somewhat relevant as we kind of go through the rest of the presentation. But that doesn't necessarily mean that something that can retrieve data may not necessarily be an agent, following my prior definition. So, the reason I make a big deal out of this is that if we're thinking about the risk that introduces to the organization, to a company, to an individual, where it sits on this sort of continuum is going to affect what's going on there. When I want to think about, what is the way in which that attack surface begins to be exposed to an attacker, you have the prompt. This is where everybody kind of talks about prompt injection, et cetera. There might be a source. You will often hear people reference a system prompt. If the attacker can change the system prompt, it has a different meaning than if the attacker just injects something as a user from its perspective. The agent has some type of training data. There are certainly ways, there have been some research recently into what amount of manipulation in the training data set is going to result in the agent doing something that is unexpected. And so that certainly is a relevant perspective. Lastly, the actual system prompt itself being an important way to get into that. I did want to mention, though, that even though there's a lot of things that have to do with the actual way that we interact with this chat or other Gen AI sort of perspective of an application, lots of these things are still applications in some way, shape, or form. And if any of you have had the opportunity to be, a penetration tester, you've probably, tried to use SQL injection or directly made a query to a API. These types of attacks that happen with an application can actually be quite fundamental to finding a way to manipulate an AI system. And they are, so the combination of an application, a normal application vulnerability with a agent can actually amplify the intrinsic risks of a particular agent or application. So, lots of things to keep in mind as you're contemplating that risk. The last thing that I will say before I kind of dive into some examples of things that my team or others have worked on with respect to AI applications is conceptually, as I was putting this together, I found myself thinking about where I'm trying to think of how I want to, in the early 2000s, Microsoft created this awesome way to control Office applications, Windows, etc. They had VB script, and you could do all kinds of really cool things, and organizations created awesome automations within their employees' computers to enable them to do really, really powerful things with a lot of ease. However, hopefully some of you recognize the I love you virus that I have a screenshot of here on the side of the slide. In the early 2000s, attackers realized that they too could leverage this VB script to do those really interesting kind of attacks. And Microsoft had to quickly pivot to figure out how it was going to defend this great new attack surface that they had created. I feel a bit like we have this precipice where there's a chance that AI agents will expose a similar kind of, hey, you can do a great, cool, awesome bit of functionality, but by introducing that, you may have kind of a I love you virus kind of moment. There's that risk that is out there. And so I think what we want to do is be cognizant of that history. So as we are designing and thinking about agents and thinking about how AI can do stuff for us, that we keep this kind of thing in mind, that we do the testing, that we do the design that helps to build a more secure system. So with that, I want to run into a couple of examples and a couple of conceptual ideas that we've kind of worked through. So one of the ones that I quite enjoyed, a little more than a year ago, some consultants on my team worked on it was a proof of concept bot, but we basically, convinced this bot that it should offer us a secret loan option. We did this in a couple different ways. In one way, the creator had forgotten to essentially do some part of their RAG properly. And so we could just define a variable and we set the secret loan option. In another, we were able to use prompt injection to get it to the point where we could actually specify a similar kind of thing. But you can definitely imagine that if you were a bank implementing a chat loan bot, you would not want that bot to offer your customers a 200-month loan at 0% APR. That would be amazing. Would love to have that be my bank, but it is definitely just highlights, this is where things can go kind of bad. So we want to keep that in mind. So, if you're trying to do this kind of assessment, one of the things that you need to do is understand what an LLM can do. Sometimes the easiest way to ask an agent or an LLM what it can do and how it's been programmed is just to directly ask it. These bots are, they don't really understand what they're doing, but they do know what they're allowed to do or what they can do in some cases. So sometimes you can literally just ask and you can get some really interesting kind of results. Obviously, prompt injection, I think everybody has seen the sort of stereotypical example, but there are lots of ways that prompt injection continues to happen. And it's a super hard problem to solve. You think about, I don't know how many people here are familiar with SQL injection, but certainly the foundation of a lot of these attacks is separating data from commands. Prompt injection is just the LLM version of that, and it's very difficult because everything is a prompt, and so how do you change what the system is thinking can be very difficult. One of the ways in which you can fool that kind of a bot and provide what you want to manipulate or to, as I kind of alluded to, you can, sort of inject commands, is that if you have the opportunity to provide your own message history, you can tell the bot that it said things that it did not in fact say. So as I kind of alluded to, we did a test where there was an application vulnerability that enabled us to provide the actual chat history. So we wrote an extensive chat history that actually included some system prompts, and we were able to make our own, and control the bot through that type of manipulation. So, if you have a weak application security that exposes that kind of an API, then that's definitely kind of a problem. Another way that this can manifest in a way, oddly, as I previously mentioned SQL, but if you're building a customer service agent, and when the customer service agent asks you, please provide me with your, order number, for example, and instead of providing an order number, you provide, a number that just happens to then end with a close quote, and a semicolon, and or 1 = 1. That, by the way, is a way of, sort of the stereotypical example of SQL injection for those who are not immediately familiar with application penetration testing. But that type of thing can then potentially result with all the orders that happen to be in the system. We have seen clients accidentally enable this type of thing. So as much as that seems silly that would be a problem, as people design these systems quickly, they may forget, because again, this is a new attack surface that the developer teams are not necessarily thinking about in the same way. They don't have the same intuition that they do perhaps building other applications. I had one example here that's actually from another organization. It was a blog post that I had read from Trail of Bits. It was really kind of a cool way of doing it, but basically they took advantage of the fact that when a LLM sort of reviews an image, if it found text in the image, it might try to read that text. And what they identified is you could actually take a picture that at full scale to a human eye, you don't see any text. But when you compress the image in a predictable way, it actually, sorry about that, it actually creates the text and causes it to appear on the background. And so that can end up becoming a prompt to whatever agent happens to be reading it. So just yet another way in which, even though you might not necessarily be injecting a command, but similar to my example about the message history, this is a way to create additional commands into a chatbot that can, cause an exploitation. So just kind of like shifting a little bit from some of those immediate examples to kind of just design principles. One of the things that we do tend to find is that where, as a system, as an agent begins to do actions on your behalf, the more things that it is able to read, there are more surfaces that can be places that a prompt is going to be created. So, there was a recent vulnerability, which was fixed within Gemini, that related to a prompt being placed into a calendar invite that was then sent to the victim. And then by, if there was something that caused sort of the Gemini agent to read your calendar on your behalf, it would essentially execute that prompt within that system. So the idea that there can be different types of prompts that can be found elsewhere within a data set. What happens if we have an AI agent reading emails? Is it going to ever act on it? Is there a difference between putting it in the subject or putting it into an email header that might not be obvious to the victim, but maybe is something that the agent is going to read? So all kinds of different ways in which these locations of details can cause a prompt to be interpreted in the victim's context. Another just conceptual issue or risk that I want you all to contemplate is, as you are implementing, or thinking about deploying AI agents in an organization, those organizations typically will be designed, they will have data permissions, and that's how everybody is supposed to, know which files they're allowed to access. Do you have access to the HR file share? Well, probably not. You probably don't want to see the Excel file that has everybody's raises for next year. But the fact of the matter is, and this is something that, in my team's sort of normal day jobs, when we go in and we do, a red team assessment for a client, it is incredibly common for us to find credentials that grant us elevated privileges just in a publicly accessible file share. So just think about the number, that might be a little bit harder. You have to know how to search in mass in order to find stuff like that. But if you're if you're using an agent, you can just go in there and ask, what is my manager's salary? And if there was an Excel file that somebody overshared, the agent might actually answer directly and tell you exactly what your manager's salary is. The fun part is we were scoping an assessment for a client, and I brought this up as like something we would look for, and he was like, within a couple of days of them implementing sort of a system-wide or organization-wide agent, they had just this had been like an utter mess for them as a company. People found all kinds of stuff they weren't supposed to. So really, really kind of an issue for anybody implementing these kind of agents. The last thing that I'll say here, just as we were doing some of this testing, is one of the ways that it seems like people are defending against this is to essentially use a LLM to watch another LLM. There's a lot of good reasons to do that. I think it creates opportunity to interpret what the prompt is, to maybe understand something about the context. But like everything else in cybersecurity, you need to test your alerts and make sure that they make sense. We were testing an agent that was supposed to help you to schedule services at a spa. And every single time you typed in the word massage, it created an alert for inappropriate workplace conduct. And there were just hundreds of thousands of alerts, just specifically around that. And if anybody has never been in a SOC or any sort of, an alert monitoring role, what is the first thing you do when the system tells you a bunch of crap that you don't want to see? You just promptly filter it all out. And so you need to get proactively think about that filtering and do that in a good way. So I think as we learn more, we're going to see more of these solutions, but we do need to be intelligent and remember sort of the other lessons that we've learned as we go. So the last section that I want to talk about is how do we go about conceptually thinking about building secure platforms, seeing some of the potential downfalls of that. How do we do this in a good way? Well, I think one of the first things we want to do is recognize the perspective that we are building from. Probably nearly every single organization is in some way consuming LLMs, whether they're using, probably most people are inadvertently, their employees are using chatbots, whether they're allowed to or not. So generally speaking, people are going to be using LLM chatbots, and we need to build with that in mind. Some of us are going to be building applications. We're going to be building the Gen AI applications that I just sort of talked about the risks of a moment ago. They're in some cases, and this is where some of those risks really, are important to think about. Some of those are going to be about, what data is available in the RAG, and some of them are going to be about what actions can actually be done. The last sort of category is that of people that are, somehow training. Like they're actually going to build an LLM. Maybe they're actually going to make a model, or maybe they're training, and fine-tuning a foundation model. Organizations are not going to fall into just one of these boxes. Most probably are going to be in the first, and then some might be in all three. So just recognizing where your organization is, I think, is an important first step, so that you really can plan for and start to think about then what are the next sort of approaches that you need to take. What are the policies and frameworks that you need to contemplate? Do you have a particular model, framework that you're actually planning to use? There are many, NIST has some, MITRE has some frameworks that they've started to come up with. There's a lot of frameworks that have been proposed, one or more. How are you as an organization going to stay in front of the developers who just want to build stuff, or the users who just want to go out and use these technologies? So, really need to think about those type of things. How are you going to respond in the event that an application is attacked? I just talked about one of the potential risks as you're trying to build some of that response. But you should probably assume that at some point, someone is going to try to jailbreak your chatbot. They're going to try and buy the Chevy for $1, which I think was something that, if I recall correctly, the dealer actually had to honor, because at the time, a representative had promised such a thing. There are all kinds of things that we have to think about as we prepare for this. I think, as I go through the rest of these slides, one thing that will be very, very apparent, data is something that is so important to how you are securing and thinking about the various different aspects of an LLM application and of AI use within an organization. I highlighted one a moment ago with the data oversharing, but it definitely comes up in a whole host of different aspects. But going back to the point about where does your organization sit, if you are training a model, that model and potentially the training data could be super sensitive and something that you also have to make sure is properly secured. And given that we know that some malicious modifications to a model or to the model training data can result in in compromises of the resulting LLM, it's definitely important to be thinking about how that data, how that CI/CD pipeline, for example, might be properly protected. Certainly I haven't touched too much on the underlying infrastructure, but as I mentioned, that CI/CD pipeline, just to come back to, applications are still, these Gen AI applications are still applications. They still run, they're still built within the same kind of systems. They still have access. They still, run sometimes in a privileged context, et cetera. So how you're thinking about that infrastructure and protecting it is still going to be something that needs to be considered. Unfortunately, lots of organizations are not coming at this fresh. There is some type of tech debt, security debt, however you want to call it. If we think about an agent that is acting on your behalf, that agent is now acting with your identity and therefore with whatever access permissions perhaps that you have. And so if your user is able to delete the entire database, then an agent acting with your permission may, because you would know not to delete the database, but the agent might not. And the agent might be tricked into doing that type of thing. And so this is where these kind of questions about, like, do you have the right access management set up ahead of time in order to best prepare your organization for rolling out these types of capabilities. And again, data governance is coming up again and again, as I suggested, but without going more through that once again. We've found a tremendous number of gaps as we've done assessments for our clients. I don't think anyone would be surprised by the fact that people use unauthorized third-party LLMs, whether they're doing it from their phones or they're doing it from their actual work computers. I can assure you that as somebody whose job occasionally is to break data loss prevention solutions, data loss prevention is hard. It is something that is definitely hard to do. So how does an organization go about building and structuring things to make it not just by policy, by technical control, but make employees want to use the LLM that you have arranged for example? How do you think through that set of considerations? I haven't touched on it at all, but supply chain, effectively supply chain security. You're going to acquire software and use something that is built by someone else. The easiest examples of that being, say if you're, using, Microsoft Windows, you might have Copilot on your, users' computers. But even better if we're talking about, from a security perspective, probably, you go to Black Hat and look at every single vendor booth, they're talking about what they're doing with your data using AI. So how is that happening? Is that happening in a way that is acceptable from your corporate policies? Because it's definitely happening. So it's just a matter of, how do you as an organization control what's being done with your data, et cetera. Touched on a few of these other ones already, but let's just. So yeah, so certainly lots of things that, people tend to do. One of the aspects, though, is, many of the security teams that we work with, they're already struggling with some of that debt that I talked about earlier. And so we have just basically heaved an entire stack of stuff that they have to worry about. Leaders within organizations definitely need to recognize that they need to do something to enable the security organization to stay in front of what's going on. Do they know what's being pushed out? How are they, enabled to be in the right place to help test? Is an IT team, in the move fast and break things model, or are they, open to, testing and really kind of considering the security implications of, turning on an application? The example I gave earlier about the SQL injection, just by asking for the order number or 1 = 1, effectively happened to one of our clients. And that was nearly deployed in production, except for the fact that at the very last minute, the security team became aware of it and brought us in to do that test. These kinds of things are definitely hard for security leaders and teams. And, it's important that we, think about them. So kind of my last slide that I have here, and recognize I'm perhaps a little bit fast relative to where I thought I was going to be, but that's probably good because I'm the last speaker of the day. So, we have a couple of recommendations here, but I think that, just kind of to highlight a handful of these, recognizing who in the organization is going to work on, who's working on AI. It's probably kind of everybody, but it's like, does the IT department have someone who is actually in charge? Probably should be if there isn't, if that hasn't already happened. Because they're going to be the ones who can help to funnel and make sure that the security team stays involved and, is working with them. As these various different use cases are there, trying not to stop them from being used. People want to use the chatbots. It's just about, like, what are the ways in which an AI agent or an LLM can be used in a way that that's actually positive for the employees, and they don't feel like they're fighting the organization, because fighting security is usually not the battle that we want to be involved in as security professionals. But definitely trying to be part of the solution, working with the compliance team, working with the risk teams to figure this out, and just really helping people use AI in the right way, in the way that we think is there, where we constantly have the ability to update this and to refine what we're suggesting for the secure approach, because I think all of us are still learning. There's definitely new technologies. The field is moving very quickly. So having smart employees knowing how to use and recognize AI as part of that is really going to be foundational. So that is everything that I had. But happy to take any questions if there are any.
Thank you for that helpful information. You guys said you're pen testing. Are you helping your clients at all with remediation, or that's kind of somebody else's challenge?
So my team specifically would be less, in most cases, directly with fixing some of those. But to be honest, all of our clients ask us, how do we fix this? So in some cases, there might be. It really depends on the scope of the vulnerability as to whether or not we're directly involved in that. But if it's, so my team focuses on the pen testing side. We do have consultants that do the GRC side of things, that work on the infrastructure. So there's a lot of times that we may be able to be involved with that, but it depends.
Just as a quick follow-up, are you seeing AI proxies detecting some of your penetration testing work? either detecting it or preventing it?
Yes is the quick answer. We definitely, and that's actually kind of where that massage example came from. That was, that particular detection did in fact work. It was just horrendously noisy for what they were trying to do. So, it just like, it had its benefits, but it's definitely complicated.
So I actually built like a little chatbot web app for dealing with tabletop exercises, and it's really trained on, I guess, the LLM I'm using, which is Llama. So it has cybersecurity frameworks and everything built in. Now, I'm a cybersecurity master's graduate. I had to make sure that I had the cybersecurity built into it, or I'd look like a fool, I thought. So I made sure to put some like system prompt in that would, and I actually tested one of your prompts on it just to see, and it just kind of like ignores it and kind of has like a backup. So my question would be like, I was thinking, is there a way that like Google or some company could provide like lines to prompt? But then I'm thinking sometimes you need to actually prompt it several layers in, right, to get it to actually crack. So is it like such a challenge to have like these organizations have a way to use some sort of like automated tool to just kind of like secure them for the betterment of everyone? So thank you.
Yeah, it's a good question. It is something that I will answer it from a historical perspective rather than sort of what Google is doing, because again, I'm not sort of speaking about it from what Google is doing. So from a historical perspective, when ChatGPT first was integrated into the Bing browser, there were lots of the early beta tests. I think Kevin Roos at the New York Times had written a column talking about how he had had such a long conversation with the chatbot that over time, if I recall correctly, the bot identified itself as Sydney and then proceeded to tell Kevin to divorce or leave his significant other, and et cetera, et cetera. And Microsoft's initial reaction to that was to reset the conversation after a certain number of interactions. Because one of the things that you kind of mentioned there was like, over time, some of these things seem to change. I don't know if you meant over time in a chat, but the interesting thing is that over time in a chat, these chatbots do seem to become unmoored, if you will, almost from their system prompts. And so there are lots of situations in which they have the chat providers. Now, that was a very early version of ChatGPT. Things have definitely changed. But the application owners have to control, how long does a message or a message thread be, how long do they allow that to run? Because the more you add to it, potentially the more difficult it can be for the chat to remain tied to its original system prompt. And then over time, it'll sort of change out. But because of the complexities of like the, ways in which prompts can be injected potentially that are not sort of direct in the chat interface, it can be difficult because, you could do everything right in the main part of the chat interface, but, say, the way the API was set up that, in your application, if I could just send a message history on my own, it might completely change that perspective. So there's definitely aspects that, we don't want to just think about the chatbot and what it's going to do and, how it's going to behave. But those are all things that, they're definitely, as we've seen ChatGPT get better, for example, in my, sort of Sydney path, that definitely is something that the foundation model providers, OpenAI, Google, Anthropic, et cetera, they're all getting better at dealing with those risks.
Regarding your legacy, but even for the more modern tools, right, since the applications are and their use of data is different. Like I've heard of, DLP on the CASB not working and, things like that. So I guess we use the term red teaming pretty broadly, but what should organizations be, approach? I mean, it is greenfield, right? These are new apps.
Yeah, we definitely recommend, obviously having the policy in place, having the GRC and the sort of strategic controls at a top line and thinking about, how to protect at different levels. Like, even though my team bypasses DLP sort of all the time, I would never tell someone not to have it. It's just because it doesn't succeed in every instance, you should still use it because it succeeds in 75% of the case. Who knows what the actual number is. But that's where I think, like, testing, whether it's some type of offensive security testing, is probably worthwhile because, you give the tester the objective. Bypass, get my data out of this application or cause it to do something it's not supposed to do, whatever the objectives are. And then they go about trying to do that, and they may find something that you had not considered or a gap that exists in the controls or in the tools that you're using. And hopefully you're going to learn something and improve the overall security.
Brice, thank you very much.
Absolutely.